Our next speaker is going to help us break down some of the barriers we face when we deal with big data, strategic decisions, and execution. Bill Schmarzo is responsible for setting the strategy and defining the big data service offerings and capabilities for EMC Global Services Big Data Practice. Bill is also the author of Understanding How Data Powers Big Business, and also the author of Big Data MBA, Driving Business Strategies and Data Science. So let's welcome Bill to the stage.
Good afternoon. This is a long way from the small town of Iowa. Charles City, Iowa to be exact, northeast part of Iowa. How many people here know where Charles City is? I gotta tell you, most of the conferences I present at, I get no hands. So it's very comforting. Big data. Has there ever been a more useless term created than the word big data? The challenge, over lunch we were talking about big data. We got talking about things like autonomous vehicles. We got talking about things like backward propagating neural networks and reinforcement learning and artificial intelligence and chaos theory. In my part-time, I teach at the University of San Francisco School of Management called the Big Data MBA. And the goal behind that class is to take and teach tomorrow's leaders how to embrace analytics as a business discipline. What I want to do today is I'm going to tear some pages out of my Big Data MBA class, and what I want to do is I want to talk about this concept of big data, but we want to simplify it. We want to simplify it to the point where you know how to act on it. Today's conversation isn't about taking the simple tasks and making them mundane. It's about taking the impossible and making them achievable. That's our goal today. And my goal is that you're going to walk out of here with at least one or two ideas, concepts, things that you can take back to where you're going to go, where you came from, and take them back and start this journey. Start it with a single step. Let's simplify this conversation. So one of the first things that I tell the clients I work with, and I'm very fortunate, I actually have the best job in the industry. I get to spend all of my time with clients, helping them figuring out not only where and how to start, but actually showing them how to get there, working with it. And then, by the way, I get to teach too, so I get a chance to see all sides. And we find that this point here, while it may seem like weasel words, just flipping a couple of bits, it's an important reframing of the conversation. You do not need a big data strategy. What you need is a business strategy that incorporates big data, that knows how to leverage data and analytics to power the business. That's the conversation we want to have. I don't want to talk about Hadoop or SQL or artificial intelligence or deep learning techniques. No, I don't. Those are all tools, right? They're tools. I want to build a house. I want to build a mansion. I want to build a castle. I'm going to use different tools to do it. Let's not fixate on the tools, let's fixate on what we're trying to achieve. So what I'm going to do, if I can pull this off, come on, technology. Here we go. The most difficult question that our clients have to answer, it's a very simple question, but it's very provocative. And the question is this: how effective is your organization at leveraging data and analytics to power your business models? How effective is your organization at leveraging data and analytics to power your business models? Most organizations have no idea how to answer that question. They don't know where they sit, and they don't know what's the realm of what's possible. So let me share with you a maturity index that we've created to help our clients not only to understand where they are, but how they become more effective. We call this, creatively by the way, the Big Data Business Model Maturity Index. Can you see that okay? Is it coming out okay? If I start to scribble, I'm just going to play my professor card and say, hey, I just scribble, I'm a professor. Right? The thing that's important about this particular discussion, it's about the business. the Ubers of the world, the Netflix of the world, the Amazons of the world, the GEs of the world, they are attacking not business operations, but business models. How do you embrace the data and analytics to know where and how inside your business model you can drive transformation? So what we find, by the way, is that most organizations from a business model maturity perspective and leveraging data and analytics tend to sit along 1 of 5 points in its maturity index. And by far, the vast majority of companies that I deal with and have dealt with, and I'm talking like probably 98%, are stuck in phase 1, that they are using data and analytics to monitor what happened. They're really good at telling you what happened. They're not very good at predicting, prescribing, or becoming intelligent. You've got this foundation, and to be honest with you, for those people who come from more of a BI data warehouse background, there's a chasm here. There's a chasm where we have not been able to take those BI technologies and data warehouse capabilities and become more real-time, more predictive, more prescriptive, and ultimately more cognitive. But we have some assets here. We've got data, and probably the most important asset we have here is you've identified your organization's key business processes. That is the things that you need to do to perfection to be successful. What to plant, when to plant it, how much fertilizer, how much irrigation, how many pesticides, how many cattle, when do you service the tractor and the combine and the harvester? You've got some really good foundational data around what happened. What we want to do is we want to take that foundation and we want to transform it. We want to explode off that. It's a great foundation. If we didn't have historical data, any new data that comes in would just be noise. So we need that perspective. Now, what's happened in the big data conversation is that big data, more than anything else, is about one word. It's about one word, and it's not the word Hadoop. It's about economics. This is totally an economics play. This is the concept and the term that's driving all the monetization of data. This is the concepts and term that's driving the transformation. But the challenge we have is leveraging economics. How do I apply the economics of big data to my key business processes? You're not going to do things cheaper, faster, smaller. What's required is a whole shift in how you think differently about how you're going to apply data and analytics to those key business processes. You're going to pick a business process and you're going to change the way you think about data and analytics. For the young ones here, you may not realize this, but for a lot of us old coots out here, we've always treated data as a cost to be avoided. We've aggregated it in our data warehouse. We've wiped out all the nuances, all the valuable stuff. It's like going wine tasting and slapping Vaseline on your tongue. We've taken all the important nuances out of the data because data is expensive. Well, in the last 3 to 4 years, data has not become expensive. In fact, it's 50 to 100x cheaper. 50 to 100x cheaper to store, manage, and analyze data than it has been traditionally. And in fact, if you're in the human genomic space, it's 10,000x cheaper. 10,000x cheaper. That's like going from an abacus to a smartphone. You can't get there. You have to approach it differently. You have to unlearn what you thought was gospel to embrace a whole different world. Now let's talk about how we're going to make this transition, how we're going to leverage economics. And there's only 4 things. There's only 4 things that big data does that helps organizations move along this maturity model. 4 things. You can remember 4 things, right? Number 1, access to all your transactional data, the complete history at the level of the individual. Everything. Think about your grocery chain, your grocery store. If you got a customer loyalty card, my grocery store has 20 years of details about every product I've ever bought, what price I paid, how many I bought, what was in the basket with it, what prices I paid, what coupons I used, what discounts I used, what time of day I went, what store I went to, what day of the week. They know everything about me. Everything, 20 years of detail. And the best they can do is to send me a generic flyer on Thursday. Hashtag failure. You have all this data. Now, you didn't have it in a data warehouse because why? We aggregated data in a data warehouse. We couldn't keep the individual transactions. We couldn't keep 20 years of every product Bill Schmarzo's ever bought. Today, you can. Every stinking transaction, every drone reading, every thing coming off these smartphones on my, or smartwatches on my wrists, right? Everything. So number one is you now have access to the most granular level of detail at the individual. We're going to briefly just mention there's a concept called analytic profiles, is how we leverage and build out the analytics at the level of the individual. Number two, all this growing wealth of unstructured data, right? We've got it internal, you've got physician notes, and you've got consumer comments and email conversations, but you've got a wealth of data externally. Clinical studies, research grants, right? You've got patent filings, you've got weather and traffic and the value of homes. We're doing a project for a hospital, and the hospital was trying to predict how many patients were going to come into the ER after a home football game. This was in Denver, right? Professional team. And the nurses knew that when they had a home game, the two hospitals that were within a 2-mile radius of the stadium had an increase in head injury, broken bones, lacerations, and head injuries. They knew it. What they didn't know was that it was 37%. If you can't quantify, you can't act. So there's a wealth of data out there that can help them to predict what's likely to happen. Number three, the ability to do things in real time, or I call it right time. Making decisions at the edge. Think about the autonomous car and how far we really are from being able to make decisions in real time at the edge. Right? The ability to process data and execute models in near real time. But in some cases, it may not be real time. We're doing this project for the hospital. We also were trying to reduce hospital-acquired infections, staph infections. So we created for every patient had an HAI score, hospital-acquired infections, that measured their likelihood to catch an infection while they're in the hospital. Staph infections are very expensive for hospitals. People die, that's bad, right? People hang in there longer, that's also bad. So every patient had an HAI score, kind of like the equivalent of a FICO score. When that patient then came into the hospital, the nurses knew they had between 3 to 4 minutes to check them over for wounds. Did they have any open wounds? Did they have, would their treatment they're going to have require a catheter? And if those two variables triggered higher on the HAI, they knew that that person's score was too high, and they had the authority, the nurse had the authority to send them directly to a room. They didn't stay in the waiting room. Where's the worst place to be in a hospital, by the way? The waiting room. Why? Because everybody's sick in there, right? You don't want to be in the waiting room. So if you have a high probability of getting a staph infection, get you out of the waiting room. And by the way, don't put them in purgatory, which is putting somebody on a bed sitting out in a hallway somewhere. Get them in a room, right? 4 to 5 minutes. That's not a real-time decision, but we knew we had the data, we had the scores, we could make better decisions. The last thing is what big data does is it predicts. It predicts. We can predict. We can go from reports about how many, how often, to predictions about how many I'm going to need and what's likely to happen. And when we start doing that, when we start applying predictive capabilities across this wealth of data at the level of the individual, organizations have crossed over this chasm into phase 2, which we call the insights phase. Now, what's interesting about the insights phase is that things that you find in the data may not actually be usable. You're looking for things in the data that might be useful. By the way, single most important word in the lexicon of a data scientist is the word might. The single most important word in the life expectancy of your business is the word might. Because if you don't have enough might moments, you'll never have any breakthrough moments. And so we are constantly looking for things in the data that might be useful, strategic, actionable material. When we find those, which by the way, they're not very often do you find them, but when you find them, they're like gold. And when we find those insights that pass, we call the SAM test, strategic, actionable material. When they pass that, what we then do is we apply prescriptive analytics. Think recommendations, right, like you get from Amazon and Netflix. And now we're using that to optimize that key business process. We're not, by the way, replacing humans. This is not Skynet. More times than not, we're looking to augment human decision making, to make the humans, the nurses, the teachers, the technicians, the engineers, the clerks, the tellers, to make them more effective at the point of customer engagement. We're not trying to replace humans, we're trying to make them more effective. By the way, if you do this process 1 through 3 across each of your key business processes, one at a time, what happens is you start gathering all kinds of cool stuff. You gather all kinds of new learnings. And there's your learnings about what I'm going to call your strategic entities, your customers, your employees, your trucks, your wind turbines, your CAT scans, your tractors, your cattle. You're going to start learning more and more about their propensities, their tendencies, their inclinations. And what happens when you, with that learning, it allows you to move to stage 4, which is the monetization phase. But you don't monetize data. You want to monetize the insights from the data. What you learn about your production, what you learn about your tractors and your cattle and your customers and your patients and your teachers and your students. It's that learning that provides opportunities for new things, new products, new services, new channels, new markets, new audiences, new partnerships. It's that white space. People try to sell their data. Most people don't really care about your data. But what you can sell them are insights. When I was vice president of advertiser analytics at Yahoo, sorry, I'm taking a short story and making it really long. When I went to Yahoo, I struggled. My first couple of months on the project, I struggled trying to figure out, how do I make our advertisers more effective across the Yahoo ad network? What data, what charts, what reports could I give them to be more successful? It was only through a very painful series of client meetings that I realized my customers at the ad agencies, the media planners and buyers and the campaign managers didn't want data. They wanted decisions. What ads to show, on what sites, targeting what audience, at what time of day, where do I put the ad, bottom, skyscraper? They wanted decisions. It was the insights that I monetized and helped make my advertisers more effective through improved decisions like Andy talked about when he introduced me. There is a stage 5. It's a metamorphosis phase, which I can't ever spell, so I just scribble it. Right, that kind of thing. This is where organizations change the way they measure. They change the way they measure and incent people. John Smale at Procter & Gamble used to always say, you are what you measure and you measure what you reward. If you want to change the culture of the company, you change how people get paid. And there's a few companies out there that are embracing this, who are leveraging and rewarding their customers, their employees for the capture and use and monetization of data. I'm not going to talk about it today, but we just finished a research project at University of San Francisco on how to determine the economic value of data. And people like to say, oh, data is the new oil. Let me leave you with this. This is a summary of the whole boring 30 pages of the research paper. Data is like new oil if and only if a single barrel of oil could be used across an infinite number of vehicles and it never wears out. You do not have an asset on your books. That single piece of that asset can be used across an infinite number of use cases and it never depletes and it never wears out. You have no asset like that. Data is like that. The economic value of data almost approaches infinity. If you think about it from an economics perspective and the marginal propensity to consume. We won't go there, it's really boring. But this is, where did that chart go? Put that chart back up there. This is a roadmap for how you get to the impossible. How you get to predictive, prescriptive, cognitive, how you change your organization. One step at a time. You can't start at monetization. Why? Because you don't know anything yet. You can't metamorphosize a company if you haven't built the cognitive capabilities of a self-learning environment. So if this is what organizations could do, by the way, on a single page, drawn out by a guy from Charles City, Iowa. I mean, come on, how hard can it be, right? So if this is the vision of what you could do, how do we get there? Let's talk about the how. So there's probably many ways that you can address this. This is the approach we've taken with our clients. We know it works. Again, there's probably many different ways to do this, but here's how we do it. We always start with a business initiative. I'm working with a logistics company right now. Their business initiative is how do they improve on-time delivering while reducing truck and driver operating costs. Missed deliveries cost them 10% of revenues a year, about $250 million. That's real money, right? Let's pick a problem. Let's pick one and start with that. What you then do is you bring together all your key stakeholders, all your key constituencies, that is the people who either are impacted or impact that business initiative, and what you want to capture from them, thank you, Andy, are the decisions. We focus on optimizing decisions. Reports give you questions. Questions aren't necessarily actionable. Data science focuses on decisions. This is important because it is around decisions that two groups, my business stakeholders and my data scientists, can now collaborate. The business users know the decision they're trying to make and they understand the nuances of that. My data scientists with the big giant brains are the ones who can figure out which neural network program is the most effective. There's like 50 of them. I thought neural network was like one thing. Then my lead data scientist goes, Schmarzo, here's how many we got. I'm like, holy cow, right? I want the big brain people to figure out what tools to use. I don't expect my data scientists to understand the business. They need to understand the tools. My business users understand the business. Decisions, if you remember anything about today's rant and rave from Bill Schmarzo, it's the importance of decisions. It's the linkage point that drives everything together. Now, in order to help brainstorm the decisions, what you want to do next is you want to capture, the predictive questions. That is, we want to transition the business users to start thinking like a data scientist. Let me give you an example of what I do with my students. If we had time here, I'd make you do this. So I take my students, I say, you've been hired by United Airlines, and you've been asked to forecast how many passengers are going to fly next month from San Francisco to Paris. That's your job. Then I say, what data might you need in order to make that forecast? And I break them off into small little groups, and they come back, and they present their information, and it's almost always the same story. They want to know how many people flew last month, last 12 months, same month 1 year ago, same month 2 years ago, how many people flew by time of day and by day, etc. They want all that important transactional data we talked about originally, right? They want that transactional data. And then the light bulbs go off. And somebody says, well, has there been a change in the exchange rate? How many days in the month? How many weekends in the month? Are there any holidays in the month? Are there any special events going on over in Europe, like Euro Cup? Are there any recent terrorist attacks? And where was the terrorist attack? And when did it happen? And how many people were hurt? And how many people did Google searches on Paris flight prices? And how many people did Pinterest pins on Paris hotels? And all of a sudden what happens is the data explodes. The data that might be useful explodes, which then allows our data scientists to go out and explore those data sources. So we start projects sometimes thinking we have 4 or 5 data sources, and before long we have 60. I want the business stakeholders to brainstorm what data they might need, and the data scientists will tell me which ones actually quantify cause and effect. Then I can tell you what architecture you're going to need, and I can tell you what technologies you're going to need. You young ones don't know this, but most conversations I have with clients start there. They start by buying technology, they start by building an architect, architecture, they build a data lake, they throw a bunch of random data in it, they throw a bunch of data scientists at it, and they wonder why nothing magical happens. This is not about magic. This is a process, step by step, of how we drive better decisions. No magic is needed when you have a process that you know can work. And by the way, put it back, it's pretty darn tootin' simple. It's a simple process. My students in my class can't believe organizations would do anything different than this. And then they go to work in the real world and realize that everybody wants to start with a silver bullet. All right, let me get back to other topics. Hopefully you found that kind of a starting point for the conversation. What I want to talk to you now is just some really basic concepts about what's going on from a big data and IoT perspective and what it means to organizations. These couple of slides here I call the amazing grasp of the obvious. Yeah, there's 1 billion people are going to visit Facebook today. And because of all these devices we're wearing around our wrists and the phones we have in our pockets and the droids flying overhead and an NSA spying on our phones, right? There's tons and tons of data being generated. And the IoT promises to make this even more astronomical, right? We're going to have by 2020 44 zettabytes of data. I'm not even sure what a zettabyte is. Oh, by the way, you know what's after a zettabyte? Yottabytes. If you get yottabytes. And I was wondering, after yottabytes, what is it? Is it Darth Vader bytes? I mean, what happens, right? So all I know is a whole shitload of data is what you're going to get, right? But what's interesting is while this data is growing and exploding around us, something more important has happened. And we can blame the Netflix and the Amazons and the Spotifys and the Pandoras of the world for this, is that our customers, our users' expectations are changing. The millennial generation expects their vendors to deliver to them insights and recommendations that help them to achieve their goals. Working with a financial services institute right now, you've probably seen their ads on TV, creating a retirement readiness index. How ready are you to retire? It's important to me, by the way, right? And delivering recommendations about what your investments should be, how much you're going to have to save, how long you're going to have to work, right? All these things that are required. They're not just giving you numbers. The leading organizations are delivering recommendations to make their users, their customers, and their employees more productive. So what happens in order to do this, which I talked about earlier, in order to get to this point, big data is not about big. Big data is about small. It's learning everything I can about every one of my customers. Their inclinations and biases and preferences and behaviors and associations and affiliations, to know them better than they know themselves. The secret of Amazon Prime. How can Amazon ship me a product the same day I ordered it? It seems like it's magic. What they've done is for every one of their customers in a zip code, they have predicted what it is you're most likely to buy and then aggregated to figure out and place those products in their local areas. Right? You start with the granular. And by the way, it's not just humans you have to get down to, right? Your farm equipment, your tractors, your wind turbines, your jet engines, your cars, they develop behaviors and tendencies. You need to understand them in detail. If you're going to do preventative maintenance, if you're going to try to optimize performance and energy consumption, you're going to want to know as much as possible about every one of your entities. And oh, by the way, other critters have behaviors as well. We can do this. We couldn't do this 5 years ago. Why? Because the economics made it impossible. 50 to 100x, sometimes 10,000x has changed the way you need to think. Not your problem, your problem. Unlearn. Unlearning's hard. Throw away what you thought were the way that you had to do things. Embrace new. let me talk about what new looks like. Let's talk about data science, because data science is not business intelligence 2.0. It couldn't be more different. And when I start my class, my students always want to know, and clients want to know, I say, oh Schmarz, what data science book should I read? What data science book is going to give me all kinds of knowledge? And I said, well, besides my books, of course, the book that you should read is the book Moneyball. Moneyball, not the movie. Watching the movie does not count. My wife went to the movie. She came back and said, what'd you think? She goes, Brad Pitt is so cute. I said, on base percentage, on base percentage. I love the book Moneyball, and in fact, I love a lot of the analogies around baseball, because baseball through sabermetrics has been wrestling with the basics of data science for a long time now. Sabermetrics got started back in 1978, I believe, right? And they've been working on this. And I love how they define the concept of data science. What is data science? Data science is about identifying those variables and metrics that might be better predictors of performance. Period. That's all it is. Let's not write a book about what is data science. Let's keep it simple. It's about identifying variables and metrics that might be better predictors of performance. The business users, I find time and time again, have the best idea of what variables to go look at. The data science team with their big giant brains tell you which ones actually are. It's as simple as that. This is the way, by the way, we've historically generated reports, the management reports and the compliance reports about how that manages our business. It tells you, how much money we've made, how much I'm going to get paid, right? Very well structured process, very rigid. You got a data warehouse, and the first thing you do is you build a schema. And the minute you build a schema, you aggregate out all the interesting relationships in the data. Data scientists, by the way, this is how I thought. I spent 25 years of my life building schemas. I was involved in the very first data warehouse project back in 1987 and 88 with Procter & Gamble and Walmart. I was part of the community that embraced and trained on this. And then when I went to Yahoo, I had to throw this away. I had to unlearn this. It was not easy. I failed and failed and failed until I finally realized the data science process couldn't be more different. The data science process starts with a decision, hypothesis. Then I'm going to go out and grab a whole bunch of data, and I'm going to drop it into my data lake Hadoop as is. I don't build in the schema. If I got video files, boom, video files go in. If I got log files, boom, log files go in. If I have photographs, boom, PDFs, boom, I don't care. I'm not building the schema. Building a schema, not only does it destroy data, it slows down the process. Speed is really important here. So I bring that data in. The data science team figures out what data they're going to go test. They bring it together. They do create a schema, but your data warehouse people are all going to faint because they build a flat file. And all my data warehouse friends say, flat file? Oh my God, you're wasting all this space. And I go, 100x. 100x. Storage is free. Time is not. Storage is free. Time to value is not. So I bring the data, I create it, I do some visualizations. Step 5 is really important. At some point in time, you have to quantify cause and effect. 37% increase in head injuries, broken bones, lacerations after a Denver Broncos home football game. I have to quantify cause and effect, and then I got to measure how good it's going to fit. And now, by the way, the first time I do this, it's not right. It's not very good. In fact, I don't know what right is until I failed enough times to feel comfortable with the results. Yogi Berra, famous catcher for the New York Yankees, had a famous quote. He says, predictions are really hard, especially those about the future. Right? We don't know what good enough looks like when we start this process. So you got to fail a lot. You got to fail fast and learn faster. You have to master the art of failure and the art of learning. You have to take risks. You got to throw new data in there. You can't be afraid to make mistakes. Every mistake you make is a reason to learn. Holy cow, the minute we get in the business world, we think mistakes are something we got to avoid at all costs. No, that's how we learn. How do we learn to ride a bicycle? You didn't just hop on and take off, right? We fell, we toddled, right? We learned by failure. Data science, you're trying to predict, prescribe, and become cognitive. You need to embrace a model like this that iterates quickly. Cost of storage, cost of technology isn't the delimiter. Time to decision value is much more important. Iterate fast. So what you're going to see then is you will start off with questions about what happened, like, how much fertilizer did I do last planting season, right? These are questions about what happened. To become predictive, it's actually pretty simple. Think about this, right? How much fertilizer did I use last season? How much will I need next season? That's easy, right? How much downtime did I have last month due to unplanned equipment maintenance? When will my equipment need maintenance next month? You can take what you already have in your BI environments, and we can flip them to make them predictive questions. Because ultimately, I want to get too prescriptive. I want to know what crops to plant, what vehicles need maintenance, when to fertilize, how much. I want help making better decisions. Augmented human decision making. Got time, I'm doing well on time here, which is good because usually I get really going here. So I'm going to walk you through an example. It's not a farming example, but I've been very fortunate I'm on the Technology Innovation Board for the city of San Jose. We're trying to create a smart city. Let me walk you through an exercise we just went through. One of the problems we're trying to address is how do I reduce fatal traffic accidents? And I have reports from publicly available data about when and where the accidents occur and how severe they are. Great starting point. So now what I want to do is, now that I know what has happened, I want to be able to predict what is likely to happen. So I can now, through the brainstorming process we just went through, we just talked about the steps, what data we might need, and I can actually build a model that predicts where I'm going to have accidents over the next 2 weeks. Right? I'm going to bring in all kinds of data. In fact, I'm going to show you in a second what kind of data. But then what I want to do is I want to prescribe. Tuesday morning after Labor Day, between 6 and 9 o'clock, I want to know exactly where to put the police cars, the emergency equipment, and the tow trucks. So I can actually become very prescriptive about where I'm going to put my assets. And eventually, I want to get cognitive. I want to know what variables are most predictive. Variable predictability is important. What's interesting is sunrise. Sunrise and where it comes up on the horizon and where you're driving plays a big impact. If you live in California and you're driving into the sun, it sucks. Right, we got suns, we shouldn't complain too much. But sunrise, as you can see on this, as you go through this, the reinforcement learning models we put in place will actually learn and the variables will change over time. When sunrise becomes less of an issue, it'll fall in value and something else will pick up. To create a learning organization, you need to know which variables are most predictive so you can take the most prescriptive actions. Let me summarize BI and data warehouse. BI is about comparative analysis. Current period, previous period, trend reports, etc. Data science is about behaviors. Behaviors at the level of the individual. I want to predict behaviors. I want to predict when somebody might want to buy something. I want to predict when they might leave. I want to predict when they might fraud. Right? I want to predict at the level of the individual. Because decisions, like predictions, are actionable. Let's talk about SMART for a second. There's this really interest about how do we create SMART, right? And I talked to you, there's smart factories and smart hospitals, and I talked about the project we're working on in the city of San Jose around smart cities. And obviously, opportunities to create smart farms. Smart hospitals, smart malls. We're doing a project around a smart airport at SFO. What is SMART? When somebody says, I want to create SMART, what do we mean by that? So let me give you our definition of SMART. Smart is the sum of the decisions that an entity is trying to make in support of its business or financial objectives. Decisions. Decisions. So if I'm a smart farm, for example, I'm probably making decisions around things such as crop planning and rotation and crop yield forecasting and livestock management. Think about it, right? There is a number of decisions that you have to make on the farm. You probably can't do them all at once. But as you knock them off one at a time, the accumulated learnings and the gathering of the data that supports that, each one becomes easier and easier. The data lake becomes a very enabling process for this. So let me kind of, yikes. Let me have Microsoft crash, because no presentation would be complete without a crash. And let's see if I can get back to real world here, okay? I think it's my computer's way of saying, Schmarzo, shut up. Taking too much time. So let's talk about some of the takeaways as you think about precision agriculture or lean farming or whatever the favorite term is you want to learn or use. Andy talked about it really well at the beginning, and I'm going to reinforce it. It's about decisions. I actually like this chart a lot. You got the decisions in the middle, the core of what we're trying to do, and all the different data sources that are out there. And by the way, the number of data sources is probably off by a factor of 10. There's tons of data out there that might be useful, depending on the decision you're trying to make. But there's a wealth of data out there that can help you make better decisions. And here's some key lessons to take away as you think about how you make this a reality. And these slides, by the way, are courtesy of a company in Mankato, Minnesota called Agalytics. I like their product a lot because they do some things really smart. Like number one, focus on your most important decisions. Take the time not only to identify the decisions you're trying to make, but prioritize them. Not all decisions are of equal value. Some are really important, some aren't. So one at a time, one decision at a time, optimize. The data and the analytics that come out of that use case form the basis of your next use cases. You build out your analytics one use case at a time. Number two, lead with recommendations. Where do I spray? How much do I spray? What am I going to use to spray? Right? The details. Take it down to actionability. It's no good to know I got a weed problem. I need to know what to do about it. Right? And by the way, one of the things that happens here is you want to capture what you did so the system can measure how effective those decisions were. Decision effectiveness is a really important part of the cognitive process. Number three, understand the financials. Making better decisions better lead to more money. We jokingly call big data about the 4 M's of big data. 4 M's of big data is make me more money. Right? Because you can leverage data analytics to make more money. So understand the financials. Take the time. Part of your prioritization process is some decisions may not be worth very much. Focus on the ones that are. And finally, build out a roadmap. Build out a roadmap that tells you not only the use cases, but also helps you to build out your data assets and your analytic assets. One use case at a time. I started out the whole presentation by saying, the objective today is not to make the simple task mundane, it's to take the impossible and make it manageable. One use case at a time. You create a smart farm, a smart airport, a smart mall, a smart city, one use case at a time, and you build out your core assets in data and analytics. So, how do you become intelligent? Well, this is a better drawing than I did. We talked about the Big Data Business Model Maturity Index as a way to move towards becoming intelligent. It's a way to go from the mundane to the impossible. And what you're going to find along that journey is that there are technologies, capabilities, right? We're going to go from descriptive analytics, we're going to jump the shark and get to predictive analytics, we're going to get to prescriptive, and eventually we're going to become cognitive. And what we mean by that is that predictive is about quantifying cause and effect. You have to know that the number of hospital visits increases by 37% if I want to know how many nurses and doctors and extra supplies to have. Around prescriptive, I really want to optimize or augment human decision making. And finally, I want to get smart. Oops, too fast. Come back here. I want to get cognitive. The system has to learn. The variables are going to change. Tell me what variables are most important so I can figure out where to invest. This is not an impossible task, but it requires organizations to do some things they don't do very well. Number one, unlearn what you've learned before. That's the hardest one. I know a lot of CIOs who have gotten to become CIOs because they backed and were supporters and champions of the organization's data warehouse initiatives. The reason why they're not adopting data science and data lakes has nothing to do with technology, everything to do with their comfort level. Number two, you have to prioritize. Not all use cases are of equal value. Spend the time up front to understand, validate, vet, and prioritize. And number three, what organizations do a really poor job of, just generally speaking, you need to focus. Nail the first use case, capture the data and analytics, do the second use case, capture data and analytics, you'll start building out your assets. Data and analytics are assets like you've never seen before. The economic value of them is staggering. Once you understand and can embrace that, then you will reach the metamorphosis stage. Thank you for your time.